Hi, sixth graders, this is Mrs. Hebert, and today we are doing lesson 14.2, and we'll be talking about polygons in the coordinate plane. So in your math journals, you're going to actually need both sides for the notes today. And so on the first, this is what the first side, the left side, should look like. You can put the title at the top, and then you need to break your paper into 3 sections, with the middle section being the largest. Then on the second page, this will be for the 4th slide, or the fourth section of your notes. Okay, in box number 1, or section number 1, I just want you to write down the definitions of these words just as a refresher. So area is the number of square units needed to cover a given surface. Reflection is how an image would appear in a mirror, like when you look in your reflection, when you look at your reflection. And then polygon is a closed figure formed by 3 or more line segments that meet only at their endpoints. And a vertex is a corner or point where lines meet. And the plural of a vertex is vertices, if you're talking about more than one corner. So go ahead and write those down. Okay, in box number 2, you're going to write this information down, and you'll need to pause the video so that you can write this down. So you're going to say, plot points on a coordinate plane to graph shapes and connect in order. So basically what we're going to do is graph some points, and we're going to connect them in order, and we will get some polygons or some shapes on our coordinate plane. So we'll start, when I look at my coordinates for A, B, C, and D, I can see that the largest value I have is 6 for point B. And so I'm going to go out 6 each direction on my coordinate plane. And really, because these are all positives, I really would only need quadrant 1. But just to show you how it would look on the coordinate plane, I did all 4 quadrants. So A is at 3, 5. And if you remember, the first coordinate is on your x-axis. And so that's over here. And it's the horizontal axis, and then y is your vertical axis. It's the second coordinate that you get in order to pair. And so we're going to go across 3 to the right because it's positive 3, and then up 5. And we're going to put a dot there, and mine will have to be approximate. Hopefully my shapes will come out, and that will be point A. We're going to label it. And then point B is 4, 6, so over positive 4 is over to the right 4. And up 6, and that's B, and you can do this better on yours. And then C is over 5, up 5, all positive. And then D is over 4, up 4. And label that. So if we connect from A to B, B to C, C to D, and D back to A, the polygon that we get is a square. Okay, then on the second coordinate plane, I'm going to have positive and negative numbers, so it's going to be a little bit trickier. But I'll start with P, which is negative 5, positive 2, so I'm going to go left 5 and up 2, and that didn't really turn out exactly where it's supposed to be, but P is about there. Q is negative 4, positive 3, so left 4 and up 3. R is 0, 3, so I stay at 0 for my X, and I go up 3. Here's R. S is over 1 and up 2. So that's S. T is over 1 and down 2. U is at 0 and down 3. V is at negative 4 and negative 3. And W is negative 5, negative 2. Now, if I were able to plot these correctly, what I would end up with if I was plotting it exactly correctly, would be an octagon. Okay, so the polygon that I would get would be an octagon if you plot those correctly and then connect them in order, which you should be able to do on yours. It's harder for me to do on mine. But you can see the idea is that you plot points on a coordinate plane and then you connect them in order and you get a shape or a polygon, a closed figure, okay, with 3 or more sides. Okay, in box number 3, we're going to find the perimeter of a polygon on a coordinate plane. So we're going to look at the perimeter, which is the distance around. And to do that, we're going to plot some points. And we're going to use an example from the book that I don't remember exactly how it goes, but basically somebody's going from their home to the library, then to the park, then to their friend's house, then to the pond, then to the store, and then they go back home. And they want to know what is the perimeter of that, how far did they go around the perimeter. So we're going to start by plotting the points, and we'll start with home at 0, 0, and we'll call that H. Then we'll plot the library, which is at 0, 4. We'll call that L. The park is at 5, 4. So we'll call that P. The friend's house is at 5, 2. So we'll call that F. The pond is at 7, 2, but we already used P, so we'll just go over, I don't know, maybe we'll just call that D for the end of pond. And then you could give it any kind of thing that you wanted. And then from the pond to the store is 7, 0. So we'll call that S. Then we're going to connect our lines from home to library, library to the park. We have to go in the order he went. Park to the friend's house to the pond, pond to the store, and then he went back home. So here's the shape that he traveled. And they want to know, what is the perimeter of that shape, which is basically the distance around. So what we're going to do first is find the distance between points and blocks. And because these are all in quadrant 1, they're all positive. So if I was using, if I was in different quadrants, the absolute value would change to, it wouldn't be positive or negative. It would just be units from 0. So we would use the absolute value. But because they're positive, we're just going to go with what we have. So we're going to say, the home to the library, we're going on the y-axis, which is the vertical axis. So because we're using the y-axis to look at the distance, because it's vertical, we're going to use the y-coordinates. So we're going to say, we're going to use y for the library and y for home, 4 and 0. So we're going to say the absolute value of 4 minus the absolute value of 0 is 4 minus 0, which is 4 blocks. So it's 4 blocks from home to the library. Now, again, because they're all positive, you don't really have to, you can already figure out without doing absolute value. Then from the library to the park, now that's a horizontal distance. We're going across, so we're going to use the x-axis. So now we're talking about the library to the park, so we're going to use the x-axis for the library and the x-axis for the park, which are 0 and 5. But when we're doing subtraction, because it's all in the same quadrant, so we have to subtract, we're going to start with the bigger number, which is 5. So we're going to say the absolute value of the park is 5 minus the absolute value of the library, which is 0 there, which is 5 minus 0. So that gives me 5 blocks. So it's 5 blocks from the library to the park. From the park to the friend's house, again, it's a vertical. Now we're back to vertical distance, so we're going to use the y-axis. So to go from the park to the friend's house, we're going to use the y for the park minus the y for the friend's house. So the absolute value of 4 minus the absolute value of 2, which becomes 4 minus 2, so that becomes 2. So it is 2 blocks from the park to the friend's house. Then to go from the friend's house to the pond, we're horizontal, so we're using the x-axis. So we're going to use the x-axis in the friend's house and the x-axis in the pond. Because the pond is the bigger value, we'll start with that. So we're going to say the absolute value of 7 minus the absolute value of 5 is 7 minus 5, so it's 2 blocks. Now the pond to the store is a vertical distance, so I'm going to use the y-axis. So I'm going to have the y-axis for the pond and the y-axis for the store. And since the 2 is bigger, we'll start there. So it's the absolute value of 2 minus the absolute value of 0, which is 2 minus 0, which equals 2. So that's 2 blocks. Then we can't forget, because he goes back home, so we have to do store to home. So when we look at store to home, we're looking at a horizontal distance. So we're going to use the x from store to home, and home is back at 0. So we're going to use the 7 in the store and the 0 in the home. So the absolute value of 7 minus the absolute value of 0 is 7 minus 0, or 7. So now that I have all my individual distances, I'm going to add them up to get my perimeter, because that's how we find perimeter. So I'm going to say 4 plus 5 plus 2 plus 2 plus 2 plus 7. And that is going to give me 22 blocks. And so that is the answer to my problem, my perimeter problem. Now in this case, when we plot these on a coordinate plane, it's really pretty easy. We can just count the units. So we didn't really have to do the absolute values and subtract them. But when you have points in different quadrants, you will need to, add or subtract absolute values. But this was a fairly easy example, so you could just look at the coordinate plane. But if you didn't have the coordinate plane, it would be good to know how to solve it without, like we learned before. Okay? Okay, in box number 4, this is going to take quite a bit of room on your page, so just, plan on pausing your video for as long as you need so that you can fix what you can fill in all this information to start with. And then when you're ready to move on, go ahead and start the video again. Okay, so for box number 4, we're going to find the area of a polygon on a coordinate plane. So now instead of perimeter, we're looking for the area. So I wrote down the 3 steps, and then we're going to do those 3 steps. So the first step is to graph the vertices and connect them in order. And remember, the vertices are like the corners of the shapes where the lines meet, and we're going to connect them in order. Then we're going to separate the polygon into known polygons. So it's going to look like it could look like a different shape. We're going to look for shapes that we know, like squares and rectangles and triangles and things like that. Things that we have formulas for solving. So we separate the polygon into known polygons, and we can use a dashed or colored line to help us see those different shapes. And then we're going to find the area of each polygon using the base and height. And then I forgot to put in the D, but basically the D is to add those areas of the 2 shapes together. But I did it at the bottom, so we'll see there. Okay, so when I look at my points, A, B, C, D, E, and F, I see that my lowest number is 0 and my highest number is 8. So I know that on my coordinate plane, I have to go to at least 8 in each, I just did it in each direction. Really, I only needed 2 in the X direction, but I just did it that way. And I went by 2s just so it wouldn't be quite so many lines and a little easier to see. So we're going to plot these points. So A is at 1, 0. So that's really going to be halfway between the 0 and the 2 on the x-axis. That's A. And I'll put that there. It's kind of hard to see mine because my stylus is so big. B is at 3, 2. So that's right here between 2 and 4 and on the 2 line. That's B. C is at 3, 5. So I'm going to go up here. And it's about halfway between there. D is at 8, 5. E is at 8, 2. and then F is at 6, 0. So if you look at just the dots, you're going to connect A to B, which is a diagonal, B to C, which goes straight up and down, C to D, which is straight across, D to E, which is straight down, and then E to F, which is a diagonal again. Okay, and so here's basically, so now I'm going to separate these into shapes. I'm going to do that with a different color. Okay, so I can see, I can draw a line here, this green line, and it will divide my shapes into a rectangle and a parallelogram. So that's what I want, because I want to be able to find the area of shapes that I know. So I know the formula for area of a rectangle, and I know the formula for area of a parallelogram. So I divided my shape into those two. Okay, so first I'm going to find the area of the rectangle. And so area of a rectangle is going to be the base times the height. So I'm going to use the line B, from B to E as my base, and from B to C as my height. And so if I do that, I'm going to remember these are all in the positive quadrant. These are all, so I want to, they're all in quadrant 1 because they're all positive. So I want to look and use, I could use absolute values. So I'm going to say, okay, from B to E, I have to subtract since they're in the same quadrant. I'm going to take the absolute value of 8 minus the absolute value of 3. So from 8 to 3. And so it becomes 8 minus 3, which equals 5. And in this case, we're going to call them feet. So that's 5 feet. For the height from B to C, we're going to say, actually this should have been height. Sorry, I messed that up. We'll call that the height, H for height. So B to C is the absolute value of 5 minus the absolute value of 2. And that becomes 5 minus 2, which is 3 feet. So to find the area, I multiply the base times the height, and I get 5 times 3, which is 15 feet squared. So that's my area for the rectangle. Now I need to find the area for my parallelogram. So the base is going to be from A to F. And so I'm going to take the absolute value of 6 minus the absolute value of, sorry, I think I had a little glitch, technical glitch. So I'm going to look for the area of the parallelogram. So I look at the base from A to F, and that's the absolute value of 6 minus the absolute value of 1. So 6 minus 1, and that gives me 5 feet. Then the height is going to be from F to the point, from F to the point 6 to X is 6 and Y is 2, because we want to use that vertical height there for the parallelogram. So if you look at it in blue, that's what I'm looking at. So my F I'm going to take as the absolute absolute value of 2 minus 0, which is 2 minus 0, so that becomes 2 feet. And my area is base times height, so I take 5 times 2, which is 10 square feet. Now to find the area of the whole shape, I'm going to add those together. So I have 15 plus 10 gives me 25 square feet, and that's my area for that polygon. So just to recap, because I know that was kind of complicated, what I did is I plotted the points, I connected them in order, then I broke the shape into known polygons, a rectangle and a parallelogram. I used the area of the rectangle, base times height, And so I took the base, the length of the base times the length of the height, and I got that area. Then for the area of the parallelogram, I took the length of the base times the length of the height, which is, remember, straight up and down, and I got that area. Then I added those together, and that gave me the area of the entire polygon. Okay, so when you're done, this is what the left side should look like, sort of, if you followed me through all of that. And then I'll show you the other side in just a moment. Oh. And then the other side of your journal should look something like this. And so hopefully this is a little easier to see on here. And so you can look at that and kind of just check that you got your shapes and everything in the right spots, just since the writing is neater on my sample because I wasn't using the stylus. And that's it. And then you'll be practicing finding perimeters and areas and plotting points to make shapes on a coordinate plane. Thank you. Good job.